Well, welcome back to my channel. Thank you very much for the very nice comments in the comments section. I apologize for the slight shakiness in the last video. Yes, I don't have a gimbal mount, but there is one pending, so hopefully it should arrive soon. I can't say when, but I do have a tripod, so I've got the camera set up, so it should be like now. This is on the tripod, so it's a little more steady, but I'm going to have to hold the camera by hand when I show some more close-up videos of what I'll be doing next. So I'll try and keep it as steady as possible. So what we're going to do today is I'll be setting up the measuring machine that you can see behind me, and I'm going to measure a ring gauge. So the idea of today's video is basically to show you how the machine works, what all the features do, and we'll take a reading. So what I'm going to do is I'm going to just leave you for 1 minute. I'm going to set up and calibrate the machine, and then I'll bring you back and we'll go from there. Okay, I've just set up and self-calibrated my Hilger Watts Horizontal measuring machine using one of my calibrated known master plane ring gauges. This particular plane ring gauge measures 3/4 of an inch minus 40 millionths. So what I've done is I've adjusted the main and vernier scales accordingly to the calibrated known size of the master gauge. So what I'll do is I'll bring the camera closer so you can see the setup, and I have another ring gauge that you will see me set up, and we will measure this. And at least you'll get to see all the other features that I explained in my first introduction video, what they do and how they perform. Okay, I'll bring you a bit closer. Okay, so I've set up the master plane ring gauge. It's clamped down. The height's been set up, locked in place. I've used the tilting axes and the forward and backward axes of the table to set the gauge in and square it up, and I move the headstock in its position. So what I did was I set the vernier scales and the main scale according to the master gauge, and you do that by releasing these two levers, and you move this hand wheel which moves the whole headstock in place in order to set the scales to the master gauge. So we've got the dash pot in place with the fishing wire. That's the setup of the master gauge. So in order for the tilt axes to operate, the red arrow must be in between the two parallel lines. The master gauge is 0.74996 of an inch. That's its diameter. So I've set the main scale and the vernier scale to the size. So the main scale is 0.74. The line must be in between the two parallel lines. And on the vernier scale, which is up above, 996. So that's 9/10 and 60 millionths. There you are there. So the 9.5, the small hairline after the 9.5 is 50 millionths. And then you have the bigger hairline, or the second biggest hairline in the vernier scale, are tenths. So at the moment where it is, so we've got 0.74, 99, that's 9/10, and then the actual line on the vernier scale is just a little bit past 50 millionths. It's set to 60 millionths. You read directly to 50 millionths and you can estimate 10 millionths. And as the line is just past the 50 millionths smaller hairline on the vernier scale, which is the scale on the top, that's 996. So that's 60 millionths. So that's set as per the master gauge. So the measuring machine is set to the master gauge, and now we will proceed to measure this ring gauge, and we'll see what it measures. So I'm going to take this off right now and put this in its place. So first things first, I need to elevate my gauge up by winding this hand wheel. You'll notice the table floats. Just want to keep it even. So you bring it up to your correct height. There. Then you lock the height in place. And you need to check to make sure that the center, that the red center line will be in between the two parallel lines, because that's the center range of the floating table. If you don't get the red line in between the two parallel lines, then you won't get a proper test when you adjust your tilt axes, because the two parallel lines are the center pivot point range of the floating table itself. Otherwise you'll have false readings when you check for your tilt axes. So that's set in, that's in between the two parallel lines. The height is in place and it's locked. Now what I will do is I will apply pressure to my internal feeler. So I adjust this knob here, and what that will do is allow the dash pot via the fishing wire to pull the internal feeler back as far as it will go. As you can see, because the table itself floats, and that's it. Now it's in contact. And this knob has a small rod which will move past the actual column itself. So the column is only in contact with the specimen under its own tension because of the dash pot. So there's no other load on the column itself. It's just the dash pot pressure, which I said in my previous video is 8 ounces of constant pressure. So now we've got constant pressure applied. The height is set, it's locked in place. We don't need to use the oscillation feature. We don't need to oscillate the table because it's a round piece anyway. So first thing, what we'll need to do now is move the table in the forward and backward motion, and you should see it on the scales. So I will bring this up. So by adjusting this, that's pushing the table forward and backwards, you will see on the main scale it moving. And what you're looking for is the center of the diameter, which effectively will be the largest reading. So you'll notice it'll keep going up, and then it will start going back on itself, which means you've reached the center of your diameter. There, that's the point. Okay. Now we'll go to the tilt axes. In this case, the specimen is going to be tilting like this. So therefore, the center of our tilt, because obviously this is a parallel bore, will be the smallest reading on the scales. So the main scale will start to move, and you'll be looking for the smallest reading, and then it'll start getting bigger and bigger on itself again. So we've got to find the smallest reading. It is very difficult to pick up when using spherical shaped feelers. You'll notice it when you use the flat feelers when measuring external surfaces. Okay, we're about there. It wasn't very noticeable. I'll do another sample with the flat anvils, and you will notice the differences in the tilt axes. Probing. Right, okay, so at the moment we've got 0.95 showing, we've got constant pressure, we've got the vernier scale up on the top, and what we need to do is adjust the vernier scale going in the upwards position in order to bring the 0.95 main hairline in between the first pair of parallel lines on the main scale. So we adjust the vernier scale until the main, in this case the 0.95 line, sits in between the pair of parallel lines, which is the 0.03 mark. There. Try and get the parallax error. It's quite right. And just see if you can notice the difference. I'm going to do the squareness, the tilt axis feature again. So I'm just going to see if you can actually pick it up. It's not as defined. It's noticeable, but it's difficult for it to pick up on the camera. There you are. It's moving. So that's the squareness feature. It's getting bigger than that. Now we're getting smaller and smaller and smaller again. And then it will reach its point, and then it'll start getting bigger and bigger again. There you go. It's getting bigger and bigger again. So we need to go back until we find our smallest point. There. Okay. So now we are square. Okay, and then you'll see the difference using this here, the forward and backward motion of the table. It will start getting smaller and smaller, and then you need to get bigger and bigger. Right, so there you are, get smaller. Right, so we need to find the largest reading. Starts getting smaller again. There. So the main scale, it reads 0.95. So if you can see, we've got the main 0.95 hairline in the middle, in between the 0.03 pair of parallel lines. So 0.95 plus 0.03, that gives you 0.98. and then you read the vernier scale, the scale on the top. So 0.98, and if you see there, we've got 40, and then if you look at the second largest hairlines on the vernier scale, that's 4.1, 4.2, 4.3, 4.4. They are tenths. So we've got 4.4, and the actual main hairline. Because it's quite difficult because you have to be careful with parallax error. But I estimate 30 millionths. So 443. So 0.98443 inches. And then if you times that by 25.4, we get 25.004 millimeters. When you convert from imperial to metric, you times by 25.4. When you convert from metric to imperial, you divide by 25.4. Okay, so that's the size of our specimen that we've just placed. And I'll just show you. You always have to make sure, in order for these features to work, that the red arrow is in between the parallel lines, because that's the center of the pivot point. That's the pivot point range of the table. We've not needed to use the oscillation feature because this is a round diameter. But if we have a square shaped part, or in fact I have got something else that I can show you where this feature is quite useful. But as it stands at the moment, because it's a round bore anyway, we've not needed to use the oscillation feature. But certainly the tilt axes, and of course the forward and back, and the height is this here. Oh, and there's something else I forgot to mention. When you set one of these machines up, there comes a spirit bubble. And these are the adjusters. There's two adjusters. And you adjust the machine until the bubble's right in the middle. Let's see if I can zoom in. Okay, so that's just the basics of how I use this machine, and yeah, I always wanted to say that these features, especially this tilt axis feature, is very useful. It's very interesting, actually. I don't have this on my SIP measuring machine. I'm not sure if there is an accessory table that comes with the SIP measuring machine that allows you for this tilt axis feature. I'm not sure, but if there is one, I don't have this. But out of a lot of the other measuring machines I've used, this is the only one that I've seen that has this feature, as well as the oscillation feature as well. So just for the record, if we were calibrating this, we would take more than one reading in the mid-plane in order to gain the mean diameter. So it's in the mid-plane, in the middle of this gauge here. But that's not what we are doing. This demonstration is solely to show you what each feature does and its capability. So in next week's episode, which will be part 2, I will set up the external feelers to measure an external diameter, and I will elaborate more with the tilt feature. This here. This will be more visible on the scales due to flatter anvils, and I'll show you a little more on the oscillation feature as well. as we can't demonstrate this on a round bore, but you'll see this. I have another component that I can add in and show you that. And this is the external feelers that I'll be setting up in next week's episode. Well, that's it for now. I hope you enjoyed today's video. If you did, do hit that like button. Don't forget to subscribe. And by all means, do leave a comment. And I look forward to seeing you in next week's episode, which will be part 2. Goodbye.